All right. Thanks everybody for coming. And this is my first time in Russia actually, and so my first JPoint. It's been amazing so far. So thanks a lot for the support. Let's start with the introduction. My name is Nikhil Nanivadekar. Twitter handle, which is customary, Nanivade, Nikhil Nanivade. I'm the project lead of Eclipse collections. So Java collections are like fairly, near and dear to heart, and I'm really close to it. If you want to know more about Eclipse collections, go to eclipse.org/collections. I want to give a disclaimer. This has nothing to do with the Eclipse IDE. The project is under the Eclipse Foundation, so it doesn't mean that you have to use the Eclipse IDE if you're using Eclipse collections. I myself I myself end up writing code in IntelliJ IDEA and contribute to Eclipse collection. So full disclaimer. The code is out on GitHub on github.com/eclipse/eclipse-collections. Feel free to go there, take a look at the repo. There are katas and getting started quick and easy. So feel free to go there, put a star on the GitHub repo for so that you can get updates with our releases and features. So today we are here to discuss about DIY collections or do-it-yourself collections. The basic motivation of this talk, and I don't like to have PowerPoints. I end up writing code, so it's going to be completely hands-on. Feel free to interrupt in between if you have any questions or anything, and I'll try to answer them, or we can take them offline. So going back, the talk is about DIY collections or do-it-yourself collections. Now, if we are to look at the JDK collections, then there are three main types of collections: list, set, and map, right? And each of these collections are there to satisfy a certain use case. List, for example, allows you to have duplicates. It maintains the insertion. It maintains the order. Okay. Set retains only unique elements. It's hashed, lookups as well as the contains are O1. Map is a mapping between a key and a value, right? But most of the times these three are not enough. You end up having to extend these collections for some business need, right? So you have to, for example, extend these collections for some business need. Now, for example, all of us are here at a conference. Let's say you have to answer a question that a particular attendee went to how many sessions? 1, 0, 1, 2, multiple, right? Now, if that's the problem statement given to you, your de facto way of doing it would be either you'll put it in a list, and for every session, you'll have the attendees in there, or a set. Or the other way is, the most logical way will be actually to create a map where the key is the attendee name and the value is the count, the number of sessions that a particular attendee went to. Now, the interesting thing over here is, this might be one use case. Then you have another use case. Let's say you go to a shopping market and you're buying vegetables, right? So you have 3 apples, 4 bananas, 1 orange. So this use case is over and over again. So there also you will have a map. So instead of that, what we are going to do right now is going to create a new type of data structure. We call it a bag or a MultiSet, okay? And both of these collections are available in many of the open source collections framework, like Apache Commons collections, Guava, as well as Eclipse collections. And while I'm building out the collections, you'll see I'll be using mostly Eclipse collections. I mean, I'm the project lead for it. So, however, you can also implement similarly in the JDK collection. So you can always have parallels there. So going back to what exactly is a bag, okay, or a multiset. A bag is like a list which allows duplicates, okay? It is like a set, but allows duplicates, okay, and is hashed, okay. It is like a map because it is a mapping of an object to count, okay. So with that, I'm going to talk less now and start to write code, because all of us here are like developers, and we would rather see it in code, right, than me just talking hypothetical, right? So the way we are going to implement it is going to be in a completely test-driven fashion, okay? And I like to use IntelliJ live templates. So let's first go with creating a bag, okay? Now, because without the bag, yeah, like it's actually amazing when I'm using live templates, because I like, especially with the TDD talk, I can always have the tests as live templates, and implementation is actually the meat of it, right? So I don't have to waste my brain to do that. All right, so let's. I have created, just an empty class of bag, okay? And in there, I'm going to start implementing stuff. So the very first one where there's a compiler error is creating a method, a static method to actually create this bag. All right. So let's quickly implement that. And again, you just let IntelliJ do its job. So and instead of this, we are going to end up not changing all of this and say t dot 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 elements. All right. And so here, return a new bag. Let's fix this. Okay, so let's for a second ignore the compilation errors so that I can explain what's going on. Now, essentially a bag, at the end of it, we still have to back it up by a map. Because again, if we revisit our three data structures, list, set, and map, a map is the most fundamental, or the closest thing that you can have to actually satisfy this business case, right? And again, going back to the question that we want to know is, what is the count of a particular element, okay? How many, right? That's the question that we have asked and we want the answer for. So let's quickly fix these, there you go, it's done. Now you can see that I have a new bag of elements, okay? Let's say I didn't have this, okay? As I mentioned before, you need to back up the bag by a map, okay? And you can have a simple, a JDK map, t comma integer, call it a backing map. Okay, now here's the interesting thing. My value is still an integer, right? An integer, it's a boxed primitive. I don't need a boxed primitive. I should be able to do with just an int, okay? Now people will argue, oh, but what if it's more than the max int value? Yeah, you can have a long, but let's stick with int for now, okay? You need to have an int, right? But with the JDK collections, you don't have the ability to create a primitive map. So what I'm going to do is I'm actually going to use the Eclipse collections primitive map. We have an object int map, okay? And it is going to be t, and okay, so basically the way you read it is object int map means the key is an object and value is always an int, as in a primitive int. And Eclipse collections comes with like other primitive data structures as well. You will see why I'm actually choosing to use the primitive map. It's not just for memory savings. I have a blog out there which explains how exactly a bag works in Eclipse collections, and you can see the performance and the memory characteristics for much more detail, and I can show the graphs towards the later later end of the session. But essentially, this primitiveness, in addition to the memory, also provides like few cool API which helps you to reduce the amount of code that you have to write. But let's end up finishing this. So this dot backing map dot put, and then here I should be able to. Oh, that's why mutable, because you should be able to mutate. And then you should be able to just iterate over these elements, and then for every element you should be able to first check whether it's there. So get element, and then you just want to say this dot backing map dot put element comma plus plus I. Okay, and let's just call it as count. Okay, So now here, the interesting thing is I cannot use this because it's a static method. So let's quickly create a constructor so that we can, just move all of this code there, and then we can use that. Okay. All right. Let us first check whether the code works or not. Okay, it works. It's green. But is it efficient? Okay. So if you look at the implementation here, whenever you're calling a get, okay, the get is also expensive. I mean, it's not that expensive, but it's expensive because it has to look up the hash code, find the element, and then the put is the exact same thing, right? And you're doing an in-place put. What if you could do everything efficiently such that it happens in one go, right? And for that, now again, this is one of the reasons why I was using Eclipse Collections map, is because I can just call update value, pass in an element, and then this requires an initial value if it is absent, which is 0. And then you're going to say into int functions dot increment. So basically, what this is going to do is, and again, let's go run this and verify that it works. Okay. Okay, it works. Now, the interesting thing over here is we still don't know whether it really works, right? You got the new bag, but does it have the elements that you require, right? So let me put a breakpoint and actually check whether it contains stuff. So yes, it does. Orange is 1, apples 1, bananas 1. But let's say I have another apples. Now, does it still work? Well, it works because it says orange is 1, apples 2, bananas 1, right? But we can't keep on doing this over and over again, right? Again, going back to the question that we are trying to ask or trying to answer is basically what is the count, right? And we have still not implemented a method which is going to give the user ability to find out the count, right? And you will say normally in a map you would just call a get, and then you have to check if the value is null. If it is null, then it has to be 0. If it is something, then you return that, right? Fine, all understandable. But the API is not intuitive. If we are designing a data structure, why not give a much more of a functional approach and tell the user or tell the developer that when you press a dot and control space, you can actually find all the list of API that is available, and then you know what? Just use one of those, right? And again, you need to give an intuitive API. So let's actually implement that. And there you go. So basically, you're going to say that for a bag, first populate the bag, then get the occurrences of apples, and get the occurrences of bananas. Okay, fairly straightforward. So let's implement it. Element, right? And now here you're going to say this dot backing map dot get element. Now here's the interesting thing, right? If you see it's an int, right? That means it has to return something, okay? If it does not return anything, like it cannot return a null because it's a primitive int, it is going to throw a null pointer exception. So the backing map which is there, which is the Eclipse Collections map, it has already taken care of this, that whenever it is a null, it just returns a 0, right? And if you don't want that, you can always pass in the default that you want, but let's for now use that because you know what? We'll just make it easy for us. Now let's run this to verify if it works. All right, it works. I have the occurrences. Any questions so far? Okay, no. Either I'm doing a wonderful job, which I believe I am, or I'm doing a terrible job, which I don't want to believe. So we'll keep going. All right, now when you end up creating this, and again, this is sort of the API design that I'm talking about. Like it's fairly straightforward to reuse the exact same collection. But if you right now see, is I'm just creating a wrapper on an already existing collection called as a map, right? All of us understand maps. But I'm trying to create a wrapper which is going to be more usable and more intuitive for anyone who can come and be like, okay, I have this question, I have this business problem to solve. How do I solve it? Fine, you have this data structure, you have this wrapper which you can use. So let's implement add occurrences and just add. So here you can see I've actually highlighted, and these are the two compiler errors, back.add and back.add occurrences. Now let's take a step back and understand why do you need both of these, okay? Let's say you have only add, but you need to add like 100 occurrences or like 1,000,000 occurrences, right? Then you'll have to call add 1,000,000 times, right? But you don't need to. But now let's say you have add occurrences only, but you don't have add, and all you're trying to do is add one occurrence, right? Then it's typing more code by saying (1), right? So that's why we are, API providers. Let's just give the user an opportunity to use both of them, okay? And so I'll first implement add, okay, and element, okay. So when I'm using add, I just do this dot backing map dot again. I can always use update value element. Initial is going to be 0. End-to-end functions dot increment, right? Done. And this is the exact same implementation. This is nothing different than what I had done here, right? It's the exact same code. But now let's try to implement add occurrences. Okay. Here, the code might or might not change. Let's take a look. Feel free to interrupt in between if you have any questions. Okay, I'm trying to go a little bit fast so that we can implement both of them. But if you have any questions, feel free to stop me. So now here, it's going to be this dot backing map dot. Now, if I use update value, right, I have to update the value by I have to do the current count plus the count which is passed to me by the user, right? I can still use this exact same code, right? Initial of 0. And then now, the function which I want to pass, that is not going to be increment by 1. It's going to be increment by count. Does that make sense, what I'm saying? So let's actually use that. End-to-end functions dot, instead of increment, you just say add. Okay. Now, interestingly, both of them use the exact same API from the backing map, which is update value, right? However, both of them have a different function. Now, that's sort of like a really cool thing about providing a good enough API, that when you have the functions which are there, all you have to do is just change, turn on and turn off some of the knobs so that it basically ends up getting it to work. Okay. Now, what I'm going to do is, again, trying to write less code. So here, I am going to take the overhead of doing (1). Okay. This also helps a few things. One, I have to do less testing, actually, right? So let's see if this still works. Not get occurrences. I need to run add occurrences. All right. So this works fine. Basically, what we are saying is the get occurrence, and here if you see, I'm actually doing get occurrences, and I'm also using add occurrences. So again, when you have to develop your data structure in a nice, organic way, because it's first the business problem that was asked to you. Sometimes you can be minimalistic and just do get, right? You don't even need the add part of it. Okay. Now moving on to the more interesting bits. Now the remove part is in my opinion more interesting than the add part. Okay. Any guesses why? Why do you think remove is more interesting than the add? No, we are going to assume this is not concurrent. It's exactly, there might not be enough occurrences for you to remove. Okay, so let's actually have a naive implementation first. And again, I'm going to do remove occurrences element, and here again the exact same API, because at the end of the day, all you're trying to do is update the value, right? And here I'm going to do decrement because you want to remove one occurrence, right? And do the same thing for remove occurrences, where, all right? And here, instead of saying add, you're just going to do subtract. Okay. Now, interestingly, what's going to happen is, let me quickly run the test. And if I have written good test, it should actually catch the bug of it there not being enough occurrences. Yes. So yeah, I have that test, which basically is this one, because I have only one orange, so it becomes 0 and -1. Okay. So let's go fix that. Okay. Now here, interestingly, I can delegate again to remove occurrences so that we only have to handle what do you say, the not enough instances in one place. Okay. So going back here, okay, here basically now there are two options that I can have, right? If my count is less than 0, or let's say less than or equal to 0, okay, I can just say this dot backing map dot put element comma 0, right? There's this one option. At the end, this should make the test pass. So you're basically capping it at 0, right? But what might be one disadvantage over here? Exactly. This, like he said, it's not interesting anymore. You can just go and remove it, right? Because at the end of the day, basically, your get occurrences method, this implementation is going to answer your question that something is 0, right? Because by the virtue of just calling get, and since it's not there, it's going to return a 0. So you don't need to have the extra baggage, of containing that one element. So let's just remove it and see if that still works. All right. So this works fine. And this was the reason why it was interesting for remove. Because with add, it's okay. You can go on adding. You can go on adding up till integer.max value. But for remove, you have to cap it out at 0. And that's like an assumption. And that's, as data structure providers or as API providers, that's the decision that we are making. That we are going to floor it at 0. Okay? Any questions so far? We have already implemented creation of a bag, adding occurrences, removing occurrences, and getting occurrences. Why not throwing an exception? So the question was, why don't we throw an exception? So we can throw an exception, but then that does not make the data structure safe enough to use, because what that would mean is you're basically, once you start throwing that exception, okay, how will you handle the cases where a user does a get? So let's say here we have oranges, apples, and bananas, right? What if it's a kiwi? When a user is doing a get occurrence on this, so let me quickly write the code here. So let's say a user does back.get occurrences, and they pass kiwi, right? Now here, should it throw an exception or should it throw 0? Yes. So the point was that this all depends on the semantics of the data structure, right? But here, if fine, you're doing get occurrences, then you're just finding the count, okay? Here, because the kiwi is not there in a bag, you would want to return 0, or do you want to throw an exception? It's like when you do a get from a map, because a particular element doesn't exist in a map, you don't throw an exception, you return a null, correct? And then the null has to be handled by the user. We're trying to make a collection which is much more safer for you to use, where you don't have to worry about the null checks, right? Now similarly, with that, in order to keep the behavior consistent, right, even on the remove occurrences, we decide to floor. Now, it's our implementation. It's do-it-yourself collection. Maybe you're the collection provider, and you say, you know what? No. The moment it goes below 0, I'm going to throw an exception, because you're not allowed to take more. right? There are also other features where, let's say I do a remove occurrences, and the subtraction which is there, that goes to negative. Because let's say I have 2, but the subtraction becomes, I'm trying to remove 3, right? And in that case, you don't even want to remove 2, right? Again, these are the knobs. Like you can have another API which says remove only if sufficient, right? So this like just by providing a nice wrapper on it, you actually get the ability to give these knobs and have more bells and whistles and customization of your own collection. Okay. So moving on. Now you are able to answer the question of how many. You are able to answer the question of add more. You are able to answer the question of remove some. Okay. Now what about our classic iteration pattern, right? Actually being able to iterate over the bag. Because again, and you will see that I'm using my own API which I just implemented, add occurrences. All we are trying to do is you're trying to iterate over the bag, and then for each and create a list and add to the list. Okay. Now here's the interesting part. The way I do the check is actually I find the count of apple, the count of banana, and the count of oranges. Right. Now interestingly, you can use even a list. From this, what you can see is if you don't want to go through the entire pain of actually implementing your own data structure, have a wrapper, you can even use a list, right? It's going to satisfy it. However, each of the count checks, each of the questions that are asked is going to be ON because you have to go on counting every single time, right? That's the reason why we are providing a wrapper on top of that map. So let's quickly implement for each, and it's fairly interesting that here, this is not going to be an object, this is going to be a consumer. Okay? Or we can even call it a procedure, which is the Eclipse Collections procedure. So here, all I want to do is this dot backing map dot for each, right? Element, comma count. Now, the interesting thing over here is how many times. Now I have the element and the count. Right? Since my data structure has to work like a list, which allows duplicates. So in a list, if you have, apple, banana, orange, apple is going to be visited twice, right? So in this case also, because we want to allow duplicates, we can't just, do this consumer dot except on element, okay? We just can't do that because that means you're losing the number of times the procedure or the consumer has to be evaluated, right? For that, in my first iteration, by mistake, I actually did count plus plus, and it went into a never-ending for loop, and I was like, what happened? My code should work. So, all right, let's see. Going back here. All right, so the for each works as well. Now, if you see the implementation of for each, basically I'm using the for each key value from the backing map, right? Now, interestingly, that tells you that you can also provide an API on the bag itself, which can let you iterate over each element and the number of occurrences that are there. Okay, so going back here, because from that implementation, it's fairly straightforward. All you're trying to do is for each with occurrences, and here I'm not going to try to have IntelliJ fix that for me, or maybe we should, but it won't. So let's go to back. For each with occurrences. Now here, what you need is, because for each with occurrences is going to give you an int for sure and an object for sure, right? So here, all you need is an object. You need an object, an int procedure of type T, okay? So basically, it's nothing but a way in which you can actually get an object as well as an int in the procedure handle, okay? So going back here, it's going to be this dot backing map dot for each key value, and you can just pass that in, and done. It works. Okay. So going back here, let's run it. Okay, so it works. So for now, we have actually, if we are to review so far what we did in the first hour, one implemented a bag, right? Bag gave utility methods to answer business-like questions, okay? Mainly count, right? Add, remove, and iterate, right? Implemented a wrapper or a wrapper collection, okay? Now, however, is the collection yet implemented, right? Can we call bag to be a collection yet? In my opinion, you cannot, okay? Why? Because bag, as yet, does not implement a collection, right? The moment you do that, that means now it opens up many more possibilities, because wherever your Java collection is used, just by providing iteration methods, you can actually end up creating your own collection. And interestingly, for you to call something a collection, you only need to override these methods, okay? And I mean, believe it or not, it's straightforward. I'm not going to go deep into implementing those actual methods, but they're fairly straightforward, where you're trying to find the size. You have the size with the map and the count. You're trying to find whether something is empty or not. You have the backing map for that. You have contains, which again straightforward. Essentially, if you go through all of this, you can see it's fairly straightforward to create your own collection, to satisfy your your business needs, to satisfy your programming need. Now the question is, do you really need it? Like right now, without me calling implements collection, I can actually just use the bag wrapper which I have created, right? To essentially end up like answering the questions that are there. But it won't let me, do interop with like other Java, classes or other Java API which is there. But sometimes it's fine. So it depends on whether you need it or you don't need it, okay? I'm going to pause here for like 10 seconds if you have any questions, and then if not, we'll move on to implementing a multimap, because that's another interesting data structure. Okay, no questions. I'm doing an awesome job. All right, so the next one is a multimap, okay? A multimap, or it's a multi-valued map, okay? Multi-valued map. Now, essentially, in a map, traditionally you always have a key and a value. So there's going to be one key and just one value. If you do a put again on the same key, the previous value gets overridden, correct? That's a feature which all of us are like quite aware of. Some of us often use it, me included, and it's interesting, right? However, sometimes you have this need of actually storing more than one value. In the exact same example that I had given before, where let's say, for example, you want to know how many sessions a particular attendee attended, right? However, if you want to also know the names of the sessions, right, then what do? Just by having a bag is not enough. You need to have a map of the attendee and all the sessions, right? So you basically need a map of a key, and a collection of values, right? That's why it's called as a multimap, or it's also called as a multi-valued map. Again, open source frameworks like Guava, Apache Commons, as well as Eclipse collections have it. So give it a go. In this, in the next, I'm going to leave like about 5 minutes for questions and answers. But in the next 20 or so minutes, we are going to end up implementing 2 multimaps, not just 1, 2. Okay? And essentially, the 2 multimaps which are there only differ in which collection. So 2 multimaps will differ only in the collections, okay, that the values are backed by. Okay, and we are going to use a list multimap and a set multimap. Okay, and so let's start implementing, right? All right. So again, my favorite. I just like live templates. It's one of my favorite things. I think so. So the creation is fairly straightforward. It's here like where I've just an empty class and I'm going to implement it in front of you. Also, the abstract class is empty. So, but this still passes. I hope so, because I'm not checking anything other than nullability. All right. So now here, let's do a put only on the set multimap, okay? Let's look at our domain first. We're trying to have a key of animal and value of different animals. In this we have cat, dog, elephant, right? You will see in order for me to even test this, I need to implement two methods. One is put and the other one is get, right? Because like I showed in the bag example, right? I can't always put a debug point and figure out what's going on. And again, for a map, since it's a multi-valued map, but at the end of the day, it's still a map, you need to provide a get or a lookup feature, a lookup API. So let's quickly implement put, and we'll implement get, and we'll end up, implementing both of them together. So, all right. Okay, key v is value, and then here get. Okay, now interestingly, even though it's a multi-valued map, at the end of the day you still need to back it up by a map. Okay, and here I can even use a normal hash map because there's nothing that special that I'm using. But again, I want to use my own map. So this is not an advertisement. It's just that Eclipse Collections is like so second nature to me that when someone ends up writing like code with collectors and everything, it like I have to always take a step back and actually read the documentation. And then the way I end up following is I actually write equivalent Eclipse Collections code. I'm like, okay, fine, this works fine. Okay, so that's why. All right, so backing map. But this map is nothing different than your, than a normal map. It just has a key and a value. Okay, so a put is going to be fairly straightforward, where you say this dot backing map dot put, right? It should be this straightforward, right? Or no? What do you think so? Yes, exactly. It needs to be a collection of values because the put will keep on, updating. Like it will keep on changing the value which the key is mapped to, or the value which the key is mapped to. So essentially, I can't just use put. I have to end up, first initializing a collection of values and then doing the put. So if I do a get, and if absent put, since I'm only implementing sets, I can just do, a set here, and then oh, that's because this is v, right? Okay, now that should work. Okay, there you go. So if it is absent, put, right? And then our job doesn't end there, because essentially you still want to get it. If it is not there, put an empty collection in that place and then update the collection. So I'm going to do current.add and then the value. Okay. Then here it's going to be a collection of v, and the get is going to be fairly straightforward, where you say backing map.get key. Okay. So let's run this. Oh, there's one more, put all. And I mean, I want to make it as basic and as generic as possible. So I want to put everything in a particular iterable. Okay, so again, this is going to be exactly the same. This is going to be done in the exact same way as put, where you're going to say backing map dot get. Let me just do that, and then here is where the interesting thing comes, because values is an iterable, right? So I can't do an add all on the iterable, right? But I can always iterate over that iterable and then just say current.add. Right? Now people will say, but okay, why don't we delegate put to put all, right? There's a fundamental reason why you don't want to do that, even though the first two lines of the code remain look pretty much the same. And the reason for that is, if you want to use put all and delegate put to use put all, then you'll always have to create a new collection, okay? Because the way it will look here is, let's say I end up commenting this for a second, I can just do this dot put all, right? And key, comma, then I'll have to create a new collection every time, right? Just to call the put, right? And that's inefficient, that's unnecessary. So that's the reason why, contrary to bags, I'm not actually delegating it, okay? I'm keeping it in place. Let's quickly run this test and see if it works fine. Right now we have implemented actually 3 methods. One is put all, and get, okay? So right now, I mean in 5 minutes. Now let's do the same thing for put list multimap, right? Now essentially, this will all pass, right? Because the API is already implemented on Multimap, right? So let me run the test, and the test should essentially fail because it expects a list, but it's now getting a set, right? But it's compile safe because it's still, both of these are still a collection, right? And again, going back to what a multimap is, it's a multi-valued map where the value collection has to retain the collection semantics, right? A value of a list should actually behave like a list. It should allow duplicates, it should retain the order, right? A value of set should behave like a set, okay? Now going back, but I don't want to re-implement this whole thing all over the place, right? Because for sets, it will look the exact same. For the list, it will look the exact same, except for one difference, right? This backing collection, which is there, and that too only at one place, at the initialization. Everything else is going to remain the exact same, right? So what do you do? Sorry? Exactly. You end up adding an extra abstract method. And I relate this to actually, if you want to have a metaphor or something, you basically make it someone else's problem. Okay, you don't have it. You don't take that to be your own problem. So what you do here is you're going to just say protected abstract collection get value collection. Sorry? Fine, we can do create value collection. I was going to do get empty value collection, but create value collection works just as well. Okay, so let me just fix this. All right, this should be done, and we should see compile errors here. And we should see a compiler error here. All right. Now hopefully this should work fine, because at the end of the day, we have not changed any implementation, but just the backing collection. Yes, there you go. So essentially, you have right now gotten 2 collections or 2 multi-maps for the price of 1, right? And now using this exact same, and again, you will see even the tests are similar, okay? But again, similar to a bag, remove is where the interesting bit comes. Not essentially for a set. So let's, or maybe even for the set. Let's look at it, how we'll end up implementing this. So let's create a method remove. Okay. Value. Okay. Now here the remove is always going to be on the backing map, right? So this is dot get key, right? Okay. And if collection not equal to null, then collection dot remove value. Again, I'm not going behind efficiency or optimization. Like we can definitely optimize it in a much more better way, right? So you're doing a remove here, right? Now what should happen in the case that the remove ends up removing everything, right? That was the last element. What should happen? Should we keep the key with you? Should the key be present in the map? Yes or no? It depends. Exactly, it depends. And the way generally a multimap is looked at, and this was actually one of the authors of Guava who answered the question on Stack Overflow. Generally, the way the multimap's contract is that if a key has an empty collection associated with it, an empty value collection, then the key is not retained in the multimap at all. And the reason for that is basically you look at it as like, a pair. So basically a key and value pair which is there all across. And if there is no corresponding value in a map, right? A map will not keep a null value, right? A key with a null value. So similarly, but the interesting thing over here is then it makes get a little bit interesting, right? Let's see why. And I'm going to say if collection, dot is empty, then basically go and this dot backing map dot remove key and just remove it. Okay, remove altogether. We'll see why get becomes interesting in a second. Let me quickly implement remove all. Okay, and remove all is going to be nothing but okay, so now here, if I were to run this, okay, remove set multimap, this might work fine or this might not. Let's see when it doesn't. Okay, it doesn't work fine for the last one, right? Where the get is there, because it's expecting an empty, whereas it's returning a null. Now, the interesting thing is we can keep it as it is, like you can always return a null which is there. But again, you're not making a collection to be safe. At the end of the day, all you're trying to do is basically create a safe and a usable wrapper on a map, like a wrapper collection which is there. And the null is not sort of alleviating that thing. So instead of that, what we can do is we can change the implementation of get, where you say get, if absent, you want to return this dot create value collection, okay? So that is going to return an empty, it's not going to put in place, but because it's empty, it's going to return the empty collection, okay? Does that make sense? Now let's run it. Again, that's the beauty of TDD. Like I don't even have to, remember which implementations I have to change and which implementations I have to code, because the tests are there which are helping me, which remind me of that. Now, let's do remove list multimap. Now, on a list, the remove is fairly interesting, right? Because let's say, for example, here, again, there's nothing for me to change. But we have two instances of a dog, right? You have cat, dog, elephant, dog. And here you're trying to remove one dog, okay? And then you're trying to remove another dog. Now, the interesting aspect of it is, should one remove of the dog end up removing both the elements, or it should remove only one? Okay, again, it depends. But by the contract of a multimap, the value collection should also retain the list semantics, right? because it has to retain the list semantics, and the semantics of a list say that only the first one will actually be removed, right? So essentially, when you end up doing a remove, it ends up just removing the first one. And I don't have to write any extra code, okay, to actually implement that. There you go. The remove list multimap, that goes through fine, okay? And so right now, just to recap, we implemented wrapper maps or wrapper multi-valued maps, okay, list multimap, set multimap. However, are these yet maps? Similar to the way I showed at bags, it cannot be a map or it cannot be a collection till you actually end up implementing a map, right? And then when you implement a map, it will end up throwing a lot of compile errors, right? And that you just have to go on fixing. These are just beauty of generics, because here you have to change it from V to a collection of V, and change all of those things. But it's fairly doable. It's not that difficult. It's not that, I would say it's not like one of the most difficult things to actually do. It's fairly straightforward to do your own collections, okay? And then at the end of it, if you are like me, a lazy programmer, you don't even have to do your own collections. Most of these are available or backed up by the JDK. And most of these other specialized ones are available in most open source collections framework. So just pick one up and use it, okay? So any questions for me? We have I think another 7 minutes left. Okay, I'm going to assume I did a wonderful, oh, there's one, thank you. Yeah. It won't.
Я бегу с микрофоном. Повторите, пожалуйста, чтобы... Кто задал вопрос? Ага. Просто будет слышно тогда на записи.
Okay. No. I just offer to change create collection to method reference, and that's it.
Sorry, create collection to what?
If you call getIfAbsent put, then you should use method reference instead of calling create collection.
Yeah,
that's it.
You can. Oh, okay. But I wanted to explain one nice subtlety of getIfAbsent put, because getIfAbsent put is actually available in 2 different versions, right? There's the value, and there's the function, okay? Yeah. And the interesting bit of this is, the getIfAbsent put, the way I have used it, and I think that's what you were alluding to, the way I have used it, it is going to create an empty collection every single call, okay? And I think that's what you're trying to point out.
Exactly.
Yeah. So
because it's mutable. If it's immutable, I wouldn't have a question.
There you go. So when I end up using a method reference there, what it's going to do is it's only going to call the create collection only when it's an empty, okay? So you won't be creating an empty collection for every put or a get call. Is that what? Did I answer your question, or did I satisfy?
Sorry, didn't get. Of course, you cannot use method reference here. You should use lambda as in get method.
No, I can use. Okay. I can use this.
Okay.
Is this a method, no? Well, trust but verify. Let's see if this runs. There you go.
Great.
This one.
Any more questions?
Yeah, there's one more there.
Hi, thank you for speech. I just wonder, is it easy to make this collection thread safe?
Is it easy? Is it possible to make? Yes. Is it easy to make? No.
Okay.
Will it be done in the next hour? Probably not.
Yeah, thanks.
It's mainly the tests.
But do you have such collections in Eclipse?
So some of them are thread safe, some of them are multi-readers. So again, it depends on which collection you're looking at. So we have synchronized as well as we have multi-reader collections which are available. So we have multi-reader lists, sets, maps, multi-maps, bags. We have synchronized as well. So.
Thank you for this talk. I have a couple of remarks regarding Get implementation. First of all, you expose implementation details, giving away inner collection, which is mutable and can be modified outside, outside, and break the inner implementation. And by the way, the other remark is that this is actually needless to create value collection every time. You just need to return a default. So we can create this empty collection once, do it unmodifiable, and the final.
Exactly, and that's I mean, you hit the nail on the head there. It's perfectly. That's exact implementation that you have in Eclipse collections actually. I just didn't go for any optimization or anything. But however, you are right. In this case, what it would actually be is the returning one should be .as unmodifiable. You know, the JDK collection doesn't have it, but Eclipse collections has that API called as .as unmodifiable. So if you look at the implementation of Eclipse collections, it always returns and you cannot mutate the value. So it's a wonderful point. Thank you for raising that.
Thank you very much. Could you please highlight some of the advantages of Eclipse collections, please?
Okay, so I've got 3 minutes. I'll try.
Yeah.
This might go for 30 minutes. Okay, first, the very first thing is it is a functional API. It is a rich and functional API. Okay. And if you look at the base iterable that we have, it's called as a rich iterable. It has upwards of 80 API, which is there, 80 iteration patterns. And they are much more intuitive. They're like, you know, for example, when we are trying to create a bag, we just end up calling count by. Okay, and it will end up returning a bag, and you can use that. Okay, you have select, collect, detect, reject. Okay. And you have some of these have also the optional variants of it in case, because until Eclipse Collections 8.0 we were compatible with Java 5, but after Eclipse Collections 8 we are now compatible with Java 8 plus. So we are also compatible with JDK 12, by the way. So Eclipse Collections is one of the early adopters of the JDK. So our builds and tests actually run on the new JDK version each time, so we make sure that we are compatible with the latest version of the JDK. Thirdly, we have specialized collections, okay, in terms of multi-reader, synchronized, chronized, primitive. We have primitive collections for all, you know, we have all primitives list, all primitive sets, all primitives maps, all primitives bags. Okay, so it's it has over 1 million lines of code, and it's just a collections framework. Okay, then just to keep it fairly short in the last 1 minute, it is highly memory efficient. Okay, and if you look at my blogs, and you can follow me on Medium, it's medium.com/Nikhil Nanivadekar. You know, I try to make it easy, except that my last name is not. But apart from that, I have published blogs which actually explain and compare and contrast in the memory benefits. So if I were to show you in bag, right, this is just a hash map where it's a key and the integer is the count, and it's the hash bag. So you can see it's about half the memory usage, right? And same thing when you change the keys and everything. Our set uses about 1/4 the memory than the hash set which is there. Our map uses half the memory, half to 1/3 the memory of what the hash map uses. And there is a series of blogs that me and one of the other committers of Eclipse collections actually post, and you can take a look at it. And your most up-to-date source is going to be in the code itself and Eclipse-collections, and also on Twitter on Nikhil Nanivadekar. So if you follow me or if you follow the Eclipse Collect handle, then it will give you, because what we do is we end up pushing different blogs to show some features of Eclipse collections so that it's to raise awareness. And I will conclude with the last point is that we have not just specialized collections, but we have a new or like a distinct new/distinct collections. Like we have bimaps, we have sets with hashing strategy, map with hashing strategy, Okay, and the interesting thing of these sets and maps are basically you can define your own hashing strategy. And I've answered a few questions on Stack Overflow, which helps you to understand how they actually work. And a few of the blogs for these are coming soon. It just depends on my bandwidth, because this is not my day job. So again, it's free open source, but it also depends on the bandwidth. So
Thank you.
With that, thanks a lot for everybody who attended. It's been a great week for me so far, and love to come again. Thank you very much.
Thank you so much.